4-1, inverse relation and reciprocal functions. So we are talking about the big concept today is what happens if we have something like y equals k over x, where x is in the denominator, okay? That makes it the reciprocal function. There are 3 ways to write it. This is just the switching it all up, like how do I get k by itself, how do I get x by itself, and those would be your answers. So looking at the first example here, it says determine if the table of values represents an inverse variation, and then fill in the table to help. So in order to determine that, all you need to do is multiply the x and y together. So if you notice, one of the things we highlighted up here is xy equals k. In order to be an inverse function, when I multiply the two together, the x and the y value, I should always get the same constant k. So if you want to pause the video and start multiplying, like 2 times 12.75, 3 times 8.5, 5 times 5.10, 6 times 4.25, 15 times 1.7. No matter what, we always get k is equal to 25.5. Therefore, yes, it is a relation because k is constant, meaning it's the same number over and over and over again. However, if we try this next example and I type in 6.6 times 3, I get 19.8. 5.5 times 5 equals 27.5. So automatically I know no, cannot be it, because I can stop there. It doesn't matter if everything else is constant. I have 2 different things that have different k's, so I'm done. Okay, sliding right along to the next example. What happens if I want to use inverse variation? So I'm told that x is 6 and y is 1/2. What is the equation that represents? So remember, to find k, we do x times y. So k equals 6 times 1/2. Hey, that's 3. So then the proper way to write the formula is to have y by itself. So that's the most popular, correct way to write it, right? Well, we just found that k was 3, so y equals 3 over x is the function. Why would I ever want to do that? Because what if I wanted to find what y is when x is 15? So I would plug in 15 for x. Well, 3/15 reduced is 1/5. So my answer is 1/5. If fractions are not your friends, type that into Desmos. 3 divided by 15. Hit your little fraction button, and that'll give you 1/5. Okay, next, how could I use this in a real world problem? So we have the amount of time that it takes an ice cube to melt varies inversely to the air temperature in degrees. At 20 degrees Celsius, the ice will melt in 20 minutes. How long will it take for the ice to melt if the temperature is 30 degrees Celsius? So recall that k equals x times y. And in this case, our x is time. Our x is the minutes, and y is the time. So that would be 20 minutes times 20 degrees is 400. So k equals 400. So we get y equals 400 over x. how long will it take the ice to melt if the temperature is 30 degrees Celsius? So instead of X, we're going to put 30 degrees there. So it's going to, if I divide 400 by 30, it's approximately 13.3 minutes to melt. So that's kind of cool. You can estimate how long it's going to take something to melt. All right, let's look at graphing a function. So notice that X is in the denominator. As always, you can use Desmos. So this is why we love Desmos, right? And when we use Desmos to graph, it makes our life a little easier. Okay, so if I go to Desmos, I want to make sure to go to the graphing one. And I do 10 divided, whoops, my 0 didn't click there, divided by X. I get something that looks like this. All right, there's a nice point, 5, 2, and -5, -2. And notice that there's some special things happening on the X and Y axis. I'm going to draw them on our other screen here. So notice when I draw these lines, I do not let them cross the X or the Y axis, because the X and Y axis are these things called asymptotes. So an asymptote just means that it's something that it's approaching but never actually touching. So if you recall, you can never divide by the number 0. So 10 divided by 0 is an error in your calculator because it's undefined. You also cannot get y is 0 because there's nothing that you could plug in there to get y as 0. That's why there's an asymptote at both. So vertical is always x equals horizontal. We always write that line as y equals. If you need a memory trick, there's an acronym called HOIVUX, and that's what it stands for. Horizontal lines have a slope of 0 and are written as y equals a number. Vertical lines are undefined in slope, and they're written as x equals a number. So in this case, the domain is everything except 0. So it goes left forever, it goes right forever, but it will never actually be on the x-axis. So here's the way mathematicians write that, because that's too many words for them to write. They put a brace here and say all x such that x does not equal 0. So that just means everything but 0. So maybe as a good note taker, you write that everything but 0 is what that means. Okay. The range is the same because it goes down forever, up forever, but it never touches this horizontal orange dashed line that I created. So we write it in the same format, but with y. And the reason that that is our domain and range is because our vertical asymptote is x equals 0. And our horizontal asymptote is y equals 0. So that's the vertical and that is the horizontal. So one last example to bring that on home. If you recall, I feel like we've done this 8,000 times. Maybe you don't feel that way. But if I have f of x is 1 over x, then I have all of these transformations that can happen where it goes left or right or up or down. So remember, plus h meant left, minus h meant right, plus k, so a number on the outside, meant up, and minus k meant down. So in this example, since I have plus 2, that means left 2. And since I have minus 4, it means down 4. So instead of having, look back at our last example, instead of having my asymptotes at 0, 0, I'm going to go left 2 and down 4 for my new asymptotes. Okay. And then I have the graphs. If you are not confident in doing that yourself, you can always use Desmos. So don't be afraid to use Desmos. Okay. And then, last but not least, your domain now is all x such that x cannot equal, and instead of 0, we moved left 2, so it cannot equal negative 2 now. For the range, it's all the y values except we move down 4, so y cannot equal negative 4. And that means that the vertical asymptote is x equals negative 2, and the horizontal asymptote is y equals negative 4. Okay, so at the bottom of the notes, here's a concept summary of everything we just talked about if you need it, but that concludes notes.